What if I told you that hidden inside these broken computer boards, burnt electronic scraps, and piles of forgotten technology, there could be tiny traces of something more valuable than most people imagine? At first glance, this looks like nothing more than useless electronic garbage: old motherboards, damaged chips, tangled wires, and discarded components scattered across dusty floors. But in places where others see waste, some workers see opportunity. And today, we're stepping deep inside a world rarely shown to the public, where electronic waste begins an extraordinary journey toward recovering precious materials. The story begins with mountains of discarded electronics. These are not shiny new devices fresh from factories. They are broken, outdated, and abandoned pieces of technology collected from homes, offices, repair shops, and scrap markets. Every motherboard tells the story of a machine that once powered someone's work, memories, or business. But after years of use, these devices become e-waste, and instead of ending their lives in landfills, they are brought here for another purpose. Inside the workshop, the process starts with careful sorting. Workers sit surrounded by piles of electronic boards and components, separating valuable pieces from ordinary scrap. This stage may look simple, but it requires sharp eyes and experience. Different parts contain different metals. Some pieces are rich in copper, others hold aluminum, and certain electronic sections may contain tiny traces of precious metals. Chips, connectors, and component legs are pulled apart and grouped separately. Nothing is wasted without inspection. Every handful of material could hold hidden value. As the sorting continues, the environment reveals how demanding this work truly is. Dust fills the air, hands move quickly, containers overflow with separated pieces. To outsiders, this might look chaotic, but behind the apparent disorder is a system built through years of practical experience. Workers know which pieces deserve attention and which materials will move to the next stage. The goal is not speed alone. It is extraction, recovering whatever value remains trapped inside these forgotten machines. But separating components is only the beginning. Once the material is sorted, preparation for thermal processing begins. The electronic waste must be transformed from recognizable circuit boards into material easier to handle and process. And this is where the atmosphere changes dramatically. Heat becomes the next tool. Nearby, workers prepare the furnace area. Fuel, containers, and layers of supporting material are arranged with surprising precision. Dry soil and natural materials may be prepared to help manage temperature and support combustion. What appears to be simple dirt or ash is often part of a carefully practiced method designed to handle intense heat. The furnace itself is not a futuristic machine filled with screens and robotic arms. Instead, it reflects local ingenuity, simple structures performing powerful work. Then comes one of the most dramatic moments in the entire process: fire. Flames begin to rise as the furnace is ignited. Smoke twists into the air while the heat builds steadily. Electronic fragments are introduced into the heated environment, and the transformation begins. Under extreme temperatures, plastics burn away, coatings break down, and materials once locked together start separating. Components that once sat perfectly inside computers are now exposed to forces strong enough to change their structure entirely. This stage is intense, demanding, and visually unforgettable. The furnace glows with heat, while workers monitor the reaction closely. Their experience becomes critical. Too little heat, and the process becomes inefficient. Too much, and valuable material could be lost or damaged. Timing matters, temperature matters, observation matters. Every decision influences the final result. As combustion continues, the original identity of the electronics slowly disappears. Motherboards no longer resemble computer parts. Instead, they become dark, brittle residue mixed with metal-rich fragments. What once looked like technology now resembles mineral ore taken from deep underground. And in many ways, that comparison is surprisingly accurate. Urban electronic waste has become a modern mine, not carved from mountains, but collected from society's discarded machines. After the heating stage is completed, the material moves forward once again. Burnt electronic residue is transported toward grinding and crushing operations. This is where another transformation begins. The grinding machine may appear rough and uncomplicated, but its role is essential. Large burnt fragments are fed inside, where powerful mechanical force breaks them into smaller particles. The goal is simple but important: increase surface exposure and create a more uniform material. The finer the mixture becomes, the easier it is to separate different substances later. The sound of grinding fills the space. Metal strikes metal, dust rises, workers guide the material carefully as the machine reduces electronic remains into crushed mixtures of powder and metallic particles. Step by step, the waste becomes increasingly refined. At this point, the process is no longer about dismantling electronics. It has entered the world of material recovery. And this is where patience becomes just as valuable as machinery. Once grinding is complete, separation methods begin. Different materials behave differently depending on weight, density, and competition. Heavier particles settle differently from lighter debris. Valuable metal-rich material may be isolated from ash, burnt residue, and unwanted fragments. Workers continue sorting, screening, and managing the mixture with practiced efficiency. For many viewers, this stage may seem repetitive, but in reality, this is where success is often decided. Precious materials do not appear as giant nuggets waiting to be collected. They exist in microscopic quantities spread across enormous amounts of waste. Recovering even tiny amounts requires persistence and enormous effort. What makes electronic recycling so fascinating is the contrast between appearance and reality. A discarded motherboard looks worthless, yet inside that small board may exist layers of engineering containing copper pathways, metallic coatings, and trace elements placed there during manufacturing decades earlier. Technology that once connected people to the digital world now becomes a source of recyclable raw material. As the process continues, workers handle increasingly concentrated material. The mixture becomes darker, denser, and more metallic. Every previous stage, sorting, burning, grinding, and separating, was preparing for this moment. And while outsiders may imagine dramatic discoveries of pure gold appearing instantly, reality is far more complex. Recovery is gradual. Tiny gains accumulate through repeated effort. The workshop environment itself tells another story. This is not merely a technical operation, it is also a human story. Behind every pile of e-waste stand people using labor, experience, and determination to create economic value from society's leftovers. Their work exists at the intersection of recycling, survival, and resource recovery. Yet this process also raises larger questions. Every year, the world produces millions of tons of electronic waste. Phones, computers, televisions, and appliances are replaced faster than ever before. Technology advances rapidly, but disposal often receives far less attention. Many devices end their lives forgotten in drawers or dumped into waste streams where their materials remain unused, and that creates both a challenge and an opportunity. Electronic recycling is not simply about profit, it is also about resources. Mining metals from the earth requires massive energy, infrastructure, and environmental disruption. But recovering metals from electronic devices introduces another possibility: urban mining. Instead of digging deeper into mountains, valuable materials may be recovered from products already created by human industry. Still, the journey is not without risks. Informal recycling methods can expose workers in surrounding environments to smoke, dust, and harmful substances if proper safety systems are absent. High heat, fumes, and chemical residues demand caution and responsible handling. Around the world, experts continue searching for safer and more efficient methods to recover valuable materials while reducing environmental impact. And that reality makes this scene even more powerful. Standing inside this workshop, surrounded by smoke-stained walls, grinding machines, and piles of electronic remains, we witness more than recycling. We witness transformation. Technology is being reborn in another form. Waste is being challenged. Value is being rediscovered. The journey that started with broken circuit boards has now passed through fire, crushing force, and separation,